Hello everyone and welcome to the 8th lesson of this Python from Scratch course, in which we're gonna expand further on what we learned previously with regards to classes and objects. And we're gonna do that by expanding our person class, which we built last time, by adding more information to it and more methods, and then showing how those could be used in a more realistic scenario. Before we do that, I would like to point out one piece of information I didn't mention last time, and that's the difference between static variables and object variables. Variables defined at this spot in the class are called static variables. I'll add a comment for that. And what that means is they're actually shared between all the instances of our class. And to showcase that, I will create a delete me variable and decide that it's a value of 5. And if I print that delete value, delete me, for person1 instance and person2 instance, I can then change that value for all the instances of our object to something different, and it will affect all of them. So if I run it now, as you can see, lines 29 and 30 caused 2 5s to be printed because delete me was 5 initially by the definition of our person class right here, and then I actually changed it to be 7 in all instances of our class, and therefore when I print the delete me of person1 and person2, again we get 7 7. On the other hand, object variables, which are defined in the constructor method, are unique to that particular instance of an object. So if I were to change the name, for example, for person1, it would by no means affect the name stored for person2. So that's just one piece of information I wanted to point out in case you were to encounter that in your coding. Now, let's try to think critically about how person class would be used in the real world. And each person is usually unrelated to another, and one's details should not affect another's. Therefore, we should delete these static variables and just define the variables once the object is initialized for them to be unique to that object. Just make sure everything works. Yes. So we deleted the static variables, but they are defined here. They are now created as new variables rather than overwriting previously. So now in this situation we were overwriting these variables, and if we remove this now, they will be created anew when the object instance is created. So now let's think about what a typical person would like to store, what we would like to store about them. Firstly, let's change name to first name and last name, because it is quite common for us to want to access first name and last name separately. And let's add another object variable for last name. And obviously we will then need to change all of these initializations to account for what we changed. We will want to change their we will want to store their age. We will also want to store their height. Anything else? We could do date of birth, but we don't know how to deal with dates yet, so let's skip it out for now. And honestly, we don't want to make it too complicated, so let's skip it with first name, age, height, and a last name for now. Now let's have a look at methods that we can incorporate into our class. This is a very simple method that just increments the age by 1, and actually it's not very useful. We wouldn't use it too often. So let's try to think of a method that would be a lot more useful, and that would be to print out all the information regarding that person in a nice manner. So let's create a print function for our class, and what it's going to do is it's going to print self.firstName. Actually, we want to say person details and add self.firstName. Add a space. Person details. We could actually say that it's name, full name. And then on the next line we would print their age. Let's not forget the space. And on the last line, actually we can print it here. Age, height. And let's make sure it works as expected. Let's comment out person2. For person1 we will also need to add a last name, as now our constructor method expects a second argument for last name and one more argument for last name. Nick Builder. I know that's not a very creative last name, but let's work with it for now. And let's call the print function. So now we are gonna call this method, and we are expecting 2 lines to be printed with details of our person. And we get a mistake because I forgot a comma to separate our arguments being passed. And let's run it again. Oh, that's interesting. Okay, the reason we actually get that error is because I forgot to pass the self argument to our print function, which is a requirement for all the methods inside our class. And if we run our code again, we will actually get one more error, just because I had a typo in here. Last name, I wanted to do it camel cased, and that's how I'm referring to it in our print function. That's why it's screaming at us that there is no attribute last name, but now that I've changed it, it should all work. And yes, it does. So we get full name, Nick Builder, age 25, height 175. Actually, we have additional spaces here, so I presume a space here is not needed as such, and it should be printed slightly nicer. Yes, full name, age, height. Actually, now that I think about it, it would be nicer to put height in a separate line, just not to conflict with anything. Yes, everything works as expected. So now we have a print method, which nicely prints out all the information we currently hold about the person. And obviously, if we were to add more information, we would have to add more lines of code here to facilitate for that, but obviously we're not going to do it for now. So that's a print method. Now let's think about what else a typical person class would use. And again, coming back to our example with a website, let's say we want to check whether a person is old enough. Is of age. It's going to take a self, obviously, because it's a class method. And actually, let's make it more flexible, because different people, the different countries have different coming of age. So obviously, in UK, it's 18, but obviously in America, that would be 21. So let's have an argument called age. And we're going to compare whether the age of our person is above that age to check whether they are of age. So let's do an if statement. If self.age greater than or equals age passed in our argument, we will return true, and else we will return false. True and false are written with capitals in Python. I forgot about that. And obviously Atom highlights it nicely for us so that we know we are dealing with booleans. So now let's print person1 dot is of age, and let's do 18. And we get true printed. That's because they are actually 25. That's what we passed in our to our constructor method. But if we were in a country where the coming of age was 27, let's say, we would get false, because 25 is below false. So it is working as expected. And now let's just try a edge case with 25, and 25 returns true because 25 is greater than or equal to 25. So that is working as expected. So that's another useful method that we can use. And now let's just add one last method to our class, which would check whether the person's height is above a certain number. For example, if you had to check whether their height is high enough to go onto a water slide or something, is tall enough. And again, it will take self and height, which we're going to be comparing against. If self.height is greater than or equal height that we are looking for, return true, else return false. And actually, let's delete increase age by 1 because that's not very useful in most scenarios. So now we have a person class which has a constructor method which will take 4 arguments: first name, last name, age, and height. And then we have 3 methods which we can use to interact with our class. And now let's have a look how we can do that. So we have person 1. Let's create 2 more people. Person 2 equals Jana, builder, 22, 165. And let's add a third person, Alice, and builder as well, 5. How tall would a 5-year-old be? I have no idea, but let's say 60 centimeters. Okay, let's do that. So now we have created 3 people as such, and all of their information is stored nicely in our instances, in our objects. And now let's see how we can do that. Let's actually store all of them in a list called people. I can type today. People, person 1, person 2, person 3. So we have store all of them in an array. And now let's iterate over that array. For person in people, if person dot is of age 20, 21, print person dot name can drink in America. And let's see how that works. We get an error because obviously our class doesn't have a name variable, it only has a first name variable. So let's change that. And we get the following output. We get Nick can drink in America and Jana can drink in America. And that's exactly what we expect because Nick is of age 25 and that is above legal drinking age in America. And Jana is of age 22. But Alice, their daughter, is of age 5 and she cannot drink in America. So as you can see, we have used all the information nicely stored in our instances of person class. And we iterated over our array. So we said for person in people. A person is just a key identifier. It could be named whatever. And so we said if particular identifier, a particular person we are working with right now is of age 21. So we called the method which we defined in our class definition. And we passed 25 as the age we want to compare against. So if this returns true, then this line will be executed. Print person first name. So again, we access information inside the instance of our class. And then we just add can drink in America. And again, we don't need a space here because comma just facilitates for that. This looks a bit weird. And now we can do the same, but for height. For person in people, if person is tall enough, and we want the person to be 170 centimeters tall, print person dot first name can go on this water slide. And let's comment this out for now so that it doesn't get in our way. And we get Nick can go on this water slide, which is again what we expected, because Nick is the only one of our people who has a height over 170, which is what we are comparing against. So as you can see, by storing information in a nice structured manner in a single place and having methods to deal with that information in a previously defined, well-behaved manner, allows us to quickly do exactly what we want. Obviously, if we had not 3 people, if we had thousands of them, it would still work exactly the same. Obviously, we wouldn't manually define them, and we would take this information from some database or something. But iterating over people and checking which ones of them are have a particular property we're looking for. Maybe we are looking for people named Nick in our database of 100,000 people, or we are looking for people aged between 18 and 25 for some particular reason. We can do it just because our information is nicely structured and we know exactly where to look for information that's needed for us to do our search. And that is why classes are such a powerful facility, not just in Python, in any programming languages. And whenever you are writing large pieces of code, it is important that you structure your code in a well-behaved manner, so that you can use it later without having to redesign it at the later stages. If you design your classes, if you think through how to design your class at an early stage, it will just stay there, and then you can just keep adding more methods or more pieces of information to it if the need arises, and you will not need to redesign it at a later stage. Anyways, that's everything we are going to learn about classes. Try to create your own class for a different piece of information, for example, for a food piece, or for a menu, or for a vehicle, a car, something like that. It doesn't matter. Class can store information about anything. Class is just a utility for you to store information in a nice structured manner, and what you use it for is up to you. So try it out in your own free time and let me know how it works out. Anyways, that's it from me for today, and thank you for joining.